Hello friends, welcome back my YouTube channel MS Maths. In this video, we will solve 2 to 3 questions for fluid dynamics. In the previous lecture, we have discussed all the topics of the fluid dynamics like introduction of the fluid dynamics, what is the streamline, streak line, and stream tube, streak tube, and basically the equation of continuity in the Cartesian coordinate system and cylindrical coordinate system we have already seen. So basically in this lecture especially we will see and we will solve the 3 different type of questions. So basically like how will we approach the questions, so we'll get in this lecture. So first of all, we have a question and we will find the solution for this question, that check whether q vector is basically the velocity is c square x I j cap minus y I cap upon x square plus y square, where c is constant for a incompressible fluid. It's so it's so basically determine the solution, of the streamline, and also check the flow of the potential kind and find the velocity potential. So these all the things we will solve or we will find in this question. First of all, we have basically we have a velocity component. So the velocity component is basically q vector is c square x j cap minus y I cap upon x square plus y square. So in this case, to find the basically the motion, like how is the motion of this, so we'll find the divergence. So check whether determine the solution of the streamline and also check the flow is the potential kind. So the basically the meaning of the flow is potential kind, it means the divergence should be 0. Okay, so we'll write to check or flow of fluid is potential kind, then the divergence of q vector should be 0. It means that you have a q vector, so we can write the q vector in this way, in the way of I cap and j cap. So basically it will be minus y into c square upon x square plus y square, okay, plus c square into x I cap. Sorry, this is basically the I cap and this is j cap upon x square plus y square. Now whenever we want to find the divergent, then we'll apply the formula of divergence. So basically the divergent formula is del dot q vector. It is nothing but basically what is the meaning of del in the respect of 2D like I and j. It will be basically dou by dou x I cap plus dou by dou y j cap and dou by dou z k cap. There is no k component, so this term will be 0. So we have I cap into I cap, it will be 1 with respect derivative with respect to x. So in this case, we'll have minus and then y and c square with a constant for this, because we are partially differentiate with respect to x. So it will be minus 1 upon x square plus y square into 2x. Okay, so the x square is 2x plus 0. In the same manner, plus x and c square will be the constant for this. So it will be minus or 1 upon x square plus y square. It will be 2y in the similar manner. Now we will simplify this. Then del dot q vector is basically the minus or basically the plus. In this case, it will be plus of 2x y c square upon x square plus y square, and it will be minus of 2xy c square upon x square plus y square. It means the divergence of q vector 0. So basically the the motion is possible. It means the motion of the fluid is possible. So basically this is the proof that the motion occurs or not in the fluid. Now, in the question that we will find the solution of streamline. So how can we find the solution of streamline, or how can we find the streamline? In the previous lecture we have already discussed this thing. Now the streamline is basically dx over u dy over v dz over w. So in this case, if you have u v w, it means it will be basically u I cap, okay. So u I cap plus v j cap and w k cap. It means q vector is nothing but u v w. These are the velocity component. So in this question we have u is equals to basically I, the coefficient of I is basically x square is basically minus y into c square upon x square plus y square. So minus y into c square upon x square plus y square, and v is basically x into c square upon x square plus y square is the coefficient of j. Then w is equals to 0. So we'll put all these value. So we'll get dx over minus y c square upon x square plus y square is equals to dy over x c square upon x square plus y square and dz over 0. We have a partial differential equation, and we can solve, or we have a scheme of the partial differential equation. This is basically the Lagrange's differential equation. So we'll find the solution for this is basically we can cancel both these things. That will get a simplified form, that minus dx over minus y and dy over x is equals to dz on 0. Now we have this first, this second and third. We can simplify this by using the scheme of the Lagrange's partial differential scheme. How can we solve? First we will take first and second, so we can get that dx over minus y is equals to dy upon x. It will basically, the x dx is equals to minus of y dy. So in this case it will be x square by 2 is equals to minus y square by 2 plus c. It is nothing but x square plus y square upon 2 is equals to c. So basically we can write it as x square plus y square something k. K is nothing but 2 into c. So this will be our equation number 1, and in the similar manner we can solve this, or you can take any 1 and third and second or third. So it will be basically dz is equals to 0 on integrating, that z is basically the constant. Now the solution is basically what it represents. It represents that we have a system of equations that x square plus y square is equals to k and z is equals to c. So we can conclude that what is the streamline, or what curve be the streamline for this particular problem or for this particular velocity of the fluid. So basically it is a circle in xy plane. It is a circle with xy in xy plane with z is equals to constant, where z axis is constant and it represents a circle. Now in the question, one thing that we have to find that its velocity or its velocity potential. So how can we find the potential function for this? The potential function should be 0 to find the velocity function. So we can find the, like for this, first the curl of q should be 0. To finding this, the curl of q should be 0. So we can find the curl in this case. Then how can we find the curl? So basically for potential function. So this example like cover all the type of concept that we have already discussed. So the curl of q vector is nothing but the determinant, basically the determinant of I cap, j cap, k cap, dou by dou x, dou by dou y, dou by dou z. And the coefficient of I is basically y c square upon x square plus y square x c square upon x square plus y square, and it will be 0. So now if you will find, then I is basically 0 minus j is basically 0 minus 0, and plus k cap is basically the solution, or in this case you will find the solution that x c square upon x square plus y, or basically the partial derivative for this is dou by dou x and x c square upon x square plus y square, and minus minus plus is basically dou by dou y, and this will be minus or minus minus plus that y into c square upon x square plus y square. So basically in this case, that after solving all this we'll get, so basically this is 0. Now by solving this, we have already discussed on this topic that it will be 0. Okay, so it will be minus of 1 upon x square plus y square, or basically wait, because of that we are differentiating with respect to y, so we'll get that x plus y whole square, and the like partial derivative for that. So after solving this we'll get the 0. Okay, then next, okay, u upon v you will apply, like basically, okay, I can write in this way that c square can get common, and this will be x square plus y square whole square, and this will be x square plus y square whole square, and x, the partial derivative with respect to x is 1, then minus it will be basically x, and into it will be 2x. Okay, and similarly in this way that it will be plus and 1 upon basically x square plus y square whole square, after applying the formula that u upon y, in this way that it will be x square plus y square, and minus is basically y into 2y, and now you are going to solve this, this will be 0. Okay, so the curl for this is 0. It means that the curl of q vector is 0, then q vector is equals to minus del upon phi, where phi is the potential function. Phi is the potential function. So the phi will be the potential function for this. Then what is the q vector is basically y c square upon x square plus y square j cap, so sorry, I cap plus x into c square, or basically the x into c square upon x square plus y square j cap, and what is the value for this is basically del over del phi into x I cap minus, because minus is here, then del over, or not del, dou over dou phi into dou y, or dou phi by dou y is basically the j cap minus dou by dou phi z k cap. So on comparing both sides, we'll get the potential function basically on comparing both sides. So what can we get, that dou over dou phi by dou z, it will be 0, because of there is no component of k cap, so this will be 0. Okay, then what can we get in the next, that dou over dou phi over x is basically y into c square upon, because of minus, okay, so y into c square, that x square plus y square. And how can we solve it? This is a partial differential equation, then we can solve that phi is nothing but tan inverse basically x by y. Okay, tan inverse x by y plus function of some y. Because of that, the partial derivative with respect to x, it means it will be the function of some y. Okay, so if it is a function of y, then it will also be 0 in the partial derivative with respect to x. Okay, instead of constant, we will consider here the function of y. Next, in the next, we can find that minus dou phi by dou y is basically the x c square upon x square plus y square with the coefficient of the j cap. Then here the phi is equals to that minus tan inverse y by x. Okay, and basically y by x into c square. Yeah, in this case there is obviously the into c square also. Okay, and plus here will be the function of x. Okay, instead of writing the constant term, we'll write the function of x and y in the opposite derivative. Now we have, if I'm going to differentiate this term with respect to dou phi by with respect to y on differentiation, then dou phi by dou y is basically what will be this? Then it will be c square into differentiating with respect to y, so it will be minus of x upon y square upon basically this will be 1 plus x upon y square. The derivative of the tan inverse x is basically 1 upon 1 plus x square, and the derivative of this x upon y is basically with respect to y is basically minus 1 upon x minus 1 upon y square. Okay, plus it will be f dash y. We have the value of dou phi by dou x. What is the value of dou phi by dou x from this equation number 1? So by equation 1 we have the value of dou phi by dou x, that will be minus of x c square upon x square plus y square will be equals to, then after solving this it will be basically minus of x upon x square plus y square plus phi dash y. Here on comparing this, basically these both terms are equal. It means by this derivative or by this like expression we'll find the phi value, and by this value we'll find the phi value. Phi value should be unique. The potential function should be unique by finding the all the terms or by comparing with all the coefficients of the I cap, j cap and k cap. But in this case that extra term will be here, that phi dash y is 0. It means that phi dash y should be 0. Okay, so phi dash y should be 0. It means that the function of y should be constant. So we have considered that earlierly, this will be the function of y, that should be the derivative of that function of y should be 0. It means that the constant term, it should be constant. So that we have the potential function is basically phi is nothing but tan inverse x upon y into c square plus some constant c. We have in this process we got the potential function here, but to verify that what will be the function of y, what will be this term, to verify that we have differentiate with respect to y and we have put. You can also do the same process with respect to this also. You can differentiate this function phi with respect to x, and at that time you will put this value and you can verify that the function, the derivative of the phi dash, or here we have written that phi of f of x, then the derivative of the f of x should be 0, then the function that should be also constant. Obviously the function phi function should be unique. Okay, and in this case the basically the phi function is always be the function of x and y. Because of that it will be, whenever you are going to differentiate, that it will be constant, or instead of constant we will we will try to assume that it should be the function of x and y, because you are differentiating with respect to z and it should be 0. Okay, instead of treating it as a constant we will treat it as a function of x or y, and now you can see the phi function should be x and y, the function of x and y. There should not the containing the z term should be here. Okay, so all these things in this question we have already discussed. Now we have the if there is a question that find the equipotential line, how can we find the equipotential line by using this function? Then we have the potential function. If you have a potential function, just put it as a constant, then find the equipotential line. To proceed with the equipotential line, so how can you find the equipotential line? Just put phi is a constant. I say that is k. So it means what is the phi? That is c square into tan inverse x by y plus c is equals to k. So it is nothing but tan inverse x upon y is basically some k1, because k minus c upon c square is nothing but some k1, or it should be like c dash. Okay, it should be c dash because c is also given in the question. So what will be this? Then x upon y is equals to tan inverse k1. It is all, sorry, not tan inverse, tan k1. It will be also the basically some constant. So x is equals to a tan, x is equals to a into y, or what is a? A is basically some constant tan k1. So basically what is this? This is the line passing through the origin. Now we have the streamline and we have the equipotential line. How can we draw all these things in a geometry? Now you can see it is very beautiful to see that how can you find the geometry of all these lines, and you can represent all these lines in the geometry. In the 3D we can easily see all these things. I say that I have this y-axis and this z-axis, x-axis. Now we have the circle first. What is the streamline? Streamline is basically the circle x square plus y square sum k, where z is equals to some constant. So it will be the circle where z will be the constant. So how can you represent this? So we can represent this as a circle like this. The similar manner. This is a family of circle like this way. This will be the family of circle. Next, in the similar manner, we can represent in this way. Okay, this will be the family of circle. And now the equipotential line will passing through the origin. This is basically the line passing through the origin. Then what will be that line? That is basically, okay, sorry. S, then the line passing through the origin in this way. So these all are the basically the line passing through the origin represents represents y is equals to some, or x is equals to some a y, and this represent the x square plus y square is equals to. So this is the geometrical meaning. And now proceed to the next question. That we have a question, basically we have a question that in this question the velocity potential, velocity component is q vector is minus by, bx and 0. Discuss the nature of fluid. So how can we find the nature of fluid? Basically nature of fluid is basically like with respect to the solenoidal, incompressible, or basically insolenoidal, rotational or irrotational. In the manner of that is asking that discuss the nature of the fluid. So if you have the q vector is basically minus of by, bx and 0, it represents basically the minus qy I cap plus bx j cap and plus 0 k cap. This is the basically the velocity. Now if you want to find the, like basically the solenoidal or compressibility depends on the divergence. Okay, if divergence with q is 0, then this will be the incompressible, and the curl is equals to 0, it means that the irrotational. Now we will find these both quantity for this particular q, then we can decide that what is the nature of the fluid. So first of all, we'll find the del dot q vector is basically the divergence. It is nothing but basically minus of by, or basically dou by dou x of minus of by plus dou by dou y of bx plus dou by dou z 0. There is no x component, so it will be 0. it is also 0 and 0. So the divergence of q vector is equals to 0. It is the incompressible fluid, or we can say that it is solenoidal fluid. Okay. Next, we'll find the curl for this. Now, curl of q vector is basically the I cap, j cap, k cap, dou by dou x, dou by dou y, dou by dou z. It will be minus of by, bx and 0. And finding the determinant is basically 0 minus 0, minus j is 0 minus 0. Okay. And plus k is basically with respect to y is basically minus of b. Okay, no, sorry. This is plus of b and minus minus plus. So it will be 2b. So it means that the curl of q vector is nothing but 2b k cap, which is not equals to 0. Whenever it is not equals to 0, it is rotational fluid. The curl is not equals to 0, then rotational fluid. Now, we can also find the angular velocity. Now, the fluid, the nature of fluid is basically solenoidal, irrotational. Then, so, therefore, the fluid is solenoidal, rotational in nature. Now, we can find the we can find the angular velocity because it is rotational. Then what is the angular velocity? So in the manner of angular velocity is basically omega square is nothing but 1 by 2 curl. So what is the curl is basically 2b k cap is b k cap. So the velocity, angular velocity is constant. There is no variable. So that with the constant velocity, it is rotational with respect to the z-axis. What it represent? It represent rotation, constant rotation with constant velocity about z-axis. It represents about z-axis. Now we have an important question which is basically related to the liquid flow in the pipe. So the liquid flow through the pipe whose surface is surface of revolution. It revolves about the y is equals to alpha plus kx square upon a. It will be basically a parabolic paraboloid. Y is equals to alpha x square. It will be the parabola on the y-axis. Because of that, if you have y is equals to alpha plus kx square upon a. The regular parabola says is basically y square is equals to 4ax, the quadratic degree for y square. So it will be the parabola on the x-axis. Whenever the quadratic power on the x-axis, then it will be on y-axis. So this parabola is basically represented in this way. This parabola basically represented in this way, where this will be 0 comma a, and it revolves about x-axis. Now, with the x-axis that minus a and x to a, minus a to a, and k is a small, so that flow is one dimensional. Where k is small, then flow is one dimensional. If the liquid enters the pipe at x equals to a of the fluid with velocity v, so that the time taken by a liquid particle to travel to length of pipe is basically this, and we have to prove this. Now, the meaning in this way that this is a parabola. Whenever it will rotate about the x-axis, what will happen? This will happen in this way. This will be basically a parabolical shape like this. Okay, I am making the proper what will be the diagram for this. I'm making the proper diagram. Okay. So basically we have a parabola in this way. So this is a parabola where this is y-axis, this is x-axis. It revolves about the x-axis. Then this will be like this. This is revolution about x-axis. Now this is basically x is equals to 0. This is x equals to minus a, and this is x equals to a. Fluid enters from x equals to minus a. Then find the time taken by this from a to a. Like two length of the pipe is basically this is basically a, and this is also the a. Then total length of this pipe is 2a. Then first of all, what is the area? Like basically what is this? The cross section is basically the circle. What is the cross section? It is nothing but a circle. So the area of circle is basically pi, and like what is the area of circle in this way? The pi into a square. Now in this case we have pi into a square. What is the radius? Radius for this. So radius will be like revolution. It will be basically the radius in the revolution. Then the area of the circle with the revolution is basically the pi into a1 plus k whole square. This will be the radius. What is the radius for this? a1 plus k whole square. So it will be pi a square 1 plus k whole square. How is it the radius? Basically the concept is when the 2D geometry will revolve about axis, will doing the revolution about the axis, it will generate a 3D. So it is basically pi into y-axis, and the radius is basically 1 plus k. So a into y-axis, then the y-axis is basically 1 plus k square. So this will be the area of this section that we have called that a square, the pi a square, and this. The area of all the three sections, this will be, I say this is a1, a2, a3. So what will be the area? The area of this section a2 is basically pi a square. This is basically a1, and a3 is basically pi into a plus k into x square by a, that is basically a square. That what we have given, that y is equals to alpha plus 1 k x square upon a. Now we have, according to question, what we have, that pi a square 1 plus k whole square into v, like basically area into like the volume of the fluid is basically the pi a square v star is equals to pi a plus k is equals to like all the in like density of the like area into volume. What is the area into volume? What is the density is basically the mass upon volume. Now we are talking about the area into volume. So the on all the three areas, like if it is a different, like whatever the fluid entering, like that obviously like exit from that particular pipe. So in this way, that then like the area into velocity is equal on the three parts. That will be pi a plus k x square upon a into, or like its whole square is basically its whole square in this case, because it is a radius, then whole square that is equals to dx by dt will be the velocity in this case, dx by dt. Here we will take the corner points is basically pi a square into 1 plus k whole square to v is equals to pi a plus k x square upon a whole square dx by dt. Okay, yeah, in this case it is basically the dx by dt, so that it will be, we can consider that 1 plus k square, or not 1 plus k square, 1 plus, sorry, it will be 1 plus k whole square into v is basically pi to pi get cancel. I'm going to take a common here, that I will get 1 plus k upon x square upon a square whole square dx by dt. So this is the final expression for this. We want to find the time. We have the velocity, oh sorry, this is not volume, this is velocity, that v into v star, that area into velocity, area and velocity, sorry for that, it is not volume, it is velocity, that we will represent with the velocity. Now we have dt, so we'll write it as, we'll take the component of v in one side, that we have 1 plus k upon x square upon a square, that whole square, upon 1 plus k whole square into v, that is basically dx. So we want to find the time is basically 1 upon 1 plus k whole square into v, integration from a to a, because there is no component of x, we can take it right and the left, like outside the expression, that 1 upon kx square, 1 plus kx square upon a square whole square dx, and the right hand side it will be t. So t is equals to 1 upon 1 plus k whole square into v. For doing the integration, we can write it as 1 plus k square x power 4 upon a power 4 plus 2kx square upon a square dx. Now we can easily do the integration for this, is basically t is equals to 1 upon 1 plus k whole square into v. So the integration is basically x plus k square x power 5 upon 5a power 4, the limit is basically minus a to a minus a to a. You can component wise integrate, then it will be 2k upon x power 3 upon 3a square, limit minus a to a. Now we have here that t is equals to 1 upon 1 plus k whole square into v is basically 2a, 1 plus 2a plus k square upon 5a power 4 is basically a power 5 minus, in this case, a power 5 minus a power 5. Okay, upper limit minus lower limit, plus 2k upon 3a square into a cube minus a cube. So this will be t into 1 upon 1 plus k square to v 2 plus, so this will be k upon 2k, yeah, k square into 2a power 5 upon 5a power 4 plus 2k upon 3a square, that is basically 2a power 3 upon 2a square, yeah. Then we can write it as t is equals to 1 upon 1 plus k whole square into v is basically 2a plus k square, or 2k square upon 5, 2k square upon 5, and it will be basically a power, or basically a power 5 upon a plus 2k upon 3 into a. So this we can find. So thanks for watching my video. Keep watching MX Maths. Thank you. Bye bye.